Hello and welcome to the lesson on circles. Now this lesson on circles is going to cover lessons 9-6 and 10-3. Okay, in your homework you're going to start out with a 10-3 and then you're going to see next week or the following week you're going to go into 9-6, so you will not have to rewatch the video. This will cover both sections. Now by definition, a circle is a set of all points that are the same distance from a given point called the circle's center. So if we have a circle like this, any point on the outside of this circle is going to be equidistant or the same distance from some point which we call the circle's center, and I'm going to put a C here. So all of these points, and like I said, anywhere in the circle, these are all going to be the same distance to this center point here. So if you have a shape where you can do that, then you know that you have the shape of a circle. When you work with circles, there's a few terms that you're going to hear come up quite a bit. Okay, one is called the circle's radius. Now the radius is the center to the side, or it's halfway across the circle, and you can see that right here. So we go from the center and it just touches one side, and there's infinitely many radiuses along the circle. Now we have a diameter. The diameter is where you go from one side and you go through the center and you hit the other side. We can even write this as the diameter is equal to 2 radii, or 2 times r. Another term you're going to hear is called the circumference. Now the circumference literally just means the distance around the outside edge of that circle. Okay, so it's kind of like the perimeter. Now the thing with perimeter though, or the circumference, is we have to use a term or something, and I'm not sure if you've seen this or not, but we're going to use a symbol called pi. Okay, so it says circumference is equal to pi times the distance, or because we know that distance is equal to twice the radius, we can say that circumference is equal to 2 times pi times r, because this 2 and this r, that really equals the distance. So sometimes it depends on what you're given, okay, or what you prefer as to which formula you use, but just know that they're the exact same formula. Now for those of you that have heard of the word pi before, probably know that pi is a number that goes on forever. It never stops or never terminates. So for some of your homework problems, you're going to see it will tell you just to use 3.14 as the value for pi. But pi goes on forever, and if it doesn't specify, I would highly suggest that you use the pi button on your calculator. For those of you that are in my class, you should have on your iPads the app called The Calculator. Okay, you might have to search it, but if you make sure that you have the scientific button clicked here at the bottom, you should have a screen that kind of looks like what you see right in here. Now the pi button is actually this button right here. If you hit the pi button, you'll see on the screen that you get this number here that pops up. Okay, now they do what we call truncate or cut off the value of pi right here, because this is a number that again is going to go on forever and ever, so it never ends. But you can see all the digits of pi that this calculator offers up. But when you're doing math problems, if it does not specify to use 3.14, then I would use this pi button on your calculator, and it's going to be far more accurate, because otherwise you're going to end up with rounding errors. So that means just that your answers will be a little bit different than maybe, like if you're in a multiple choice problem, maybe than what they have. Now this here is a little demonstration that you could do if you want to find the area of a circle. So what you would do is you would get something that's circular, okay, and you could either use a compass or you could trace something like a cereal bowl or something like that. Then what you could do is you could fold that circle in half and then half again, and then fold it in half a third and a fourth time. So what that should give you is it should give you 16 wedges okay, essentially that have the folds that you see in this piece. Then if you cut those 16 wedges out and arrange them in a shape that looks like this, you'll notice that what we actually come up with is a parallelogram. Now on this parallelogram, we know that our height, so our height is going to equal the radius of this circle, because that's what each of these lines in from the triangles represent. And the base, which is what we have down here, so our base is actually going to equal 1/2 of the distance around the circle, okay, because I have half down here and I will have half of them up here. So this is going to become 1/2 the circumference, okay, and we know that circumference is equal to pi times either d, or it would be 1/2 times 2 pi r. So if we go and we look at the area of a parallelogram, we know that the area of a parallelogram was base times height. So if I use this here analogy and I apply what I know for my base, which I have right here, and my height right here, I have a base that is 1/2 times, and I'm actually going to use the 2 pi r because my height is in terms of radius, not diameter. So if I have 1/2 times 2 pi r, and again, this here's my base, and I multiply it by my height, which we said was r, what this ends up giving us is my 1/2 and 2 are going to cancel, and then I have pi, and then r times r is going to give me r squared. So the area of a circle then is going to be pi r squared, and we'll go over this here in just a second. So the true definition for the area of a circle then is equal to pi r squared. And I showed you how we came up with that. You don't have to memorize that, but I just kind of wanted to give you a little bit of background information. So here again, you're going to take pi, which you can pull right off your calculator, or you can use 3.14 if it says, and we multiply it by the radius raised to the second power. So example 1 wants us to find the circumference. So that's C, circumference of the circle. And when I look at this circle here, I see that we are given the diameter. So that tells me for my circumference formula, I can use the formula pi times d. So what this is going to do is, now I'm going to write 3.14 down. You would use the pi button on your calculator, and I'm going to multiply that by 6 feet. Now keep in mind that when you multiply this out, circumference is really a distance around the outside of that circle. So your unit is going to stay as feet. No feet squared or feet cubed. It's going to stay as just feet. So 3.14 times 6 is going to give me 18.84 feet. And that's how we find the circumference. Now for example 2, we have a story problem, and it says the size of a jaguar's territory depends on how much food is available. In a situation where there is plenty of food, the circular territory of a jaguar may be as small as 3 miles in diameter. So if I were you, I would go ahead and draw a circle just to kind of have a picture, and I'm going to even write in that I have a 3-mile diameter. So this is 3 miles. So I know it's diameter and not radius. We have to find the area of such a region to the nearest square mile. So area is going to be pi r squared. And in this case, I was given a diameter equal 3. So remember, your radius is equal to 1/2 times your diameter, or 1/2 times 3. So that's going to give me 3/2. So when I go ahead and I plug everything in that I need, I really have pi times 3/2 squared. And remember, squared is really, if you don't know how to use the squaring button on your calculator, you can just go 3/2 times 3/2 if you want. So to write this down, I'm going to go 3.14, which is pi, times, you can either do 1.5 or 3/2 squared. And when I multiply this out, I end up with 7.065, and this would be square miles because it was an area. So roughly, the area of the region is about 7 square miles. Example 3 now is going to incorporate a little bit of review from what we learned before, plus what we just learned about circles. So it says a pound of grass seed covers approximately 675 square feet. Grass seed comes in 3-pound bags. Find the area of the lawn at the right below, and we need to figure out how many bags of grass seed we need to buy to cover the lawn. So it looks like we have 2 areas. We have the area of the rectangle and the area of the circle. So the area of the rectangle is going to be length times width, which is really 45 feet times 25 feet, which gives us 1,125 square feet. And that was area of the rectangle. Then the area of our circle, pi r squared. Now if you notice though, here we only have a half a circle. So I'm going to bring a 1/2 out up front so that I only account for half the circle and not the full thing. So now I can go ahead and plug everything in. I have 1/2 times, and I'll use 3.14 times our r value. Well, r is really going to equal 30 divided by 2 because we're given the distance in terms of the diameter, which is 30 feet. So this will give us 15 feet. And I do have to square that. So when I multiply this stuff all out together, I end up with 353.25 square feet. Now for the total area, I'm just going to add those two together. So I have 1,125 plus 353.25, and I end up with a total area of 1,478.25 square feet. So that's the area of my grass region. Now remember, a bag of grass seed only covers 675 square feet. So now to figure out how many bags of grass seed we need, I'm going to take that 1,478.25 and we're going to divide that by 675 square feet. And notice my units are going to cancel out, and this is going to tell me the number of bags. So when I divide this out, I end up with 2.19 bags. Well, in real life, you can't buy a portion of a bag, so ultimately, I'm going to have to buy 3 bags of grass seed to cover everything that needs to be covered on this lawn. And now for our last example, it says find the area of the shaded region to the nearest tenth. So again, we have a rectangle on the outside here, and then we have this semicircle right there. So I'm going to find the area of my rectangle, and then we're going to have to cut out that semicircle. So the area of the rectangle is going to be length times width, which is going to be 10 centimeters times 5 centimeters, which is going to give us 50 square centimeters. The area of our circle, remember, is pi r squared, but again, I'm only dealing with half of it, so I'm going to put a 1/2 in the front, and this is going to leave me with 1/2 times pi, or 3.14, times our radius. Now in this case, they give us our actual radius, so I can use the 2.5 centimeters, and we do have to square that. So when I multiply all this together, I end up with 9.8125 square centimeters. And this again was the area of the circle. So now to find our total area, I'm going to take the area of my rectangle, which was 50, and I'm going to subtract the 9.8125, and I'm going to get an area of 40.1875 square centimeters. So I took my big rectangle, I subtracted out this little semicircle there, and that shaded region then is 40.2 roughly square centimeters. Please let me know if you have any questions. Otherwise, have a great day.